Welcome to Dreamforce. Thank you for taking time to join my session on advanced prompt engineering. Please provide feedback regarding my session and I have a chance to win a Starbucks gift card. Thanks again for coming. And let me introduce myself. My name is Ramanathan Pachepan. I'm a Salesforce architect with a company called Fujitsu. And my day job involves working with complex order management systems built using Salesforce platform. And Fujitsu is a consulting and an ISV partner. We do provide an AppExchange solution called Glovia Order Management. Please check us out at appexchange.com. And this is our agenda for today. So we are going to quickly review some of the basic concepts of the prompting. And then we are going to look at some of the advanced prompting techniques with some cool demos. And we'll get going from there. I'm pretty sure most of you are already aware of large language models, and you might have used GPT for your personal or business use cases. Let me do a quick recap. Large language models are AI models trained on huge volume of data. They are very good at language reasoning and next token prediction. I want to pay attention to the language reasoning part because the model sees all the data as a text and then converts them to numbers and produces an output which is also a number. Then later on it's decoded into a human readable text. That's at a high level. Even though the model is only text-based, inherently it does not have any logical or arithmetic processing capabilities. However, if you can nicely write a prompt and ask the model to execute it, it will understand and execute those arithmetic or logical problem and provide an output for you. That's something to keep in mind. There are several ways to optimize LLM. I mean, the first one is prompt engineering. That's the scope of our discussion today. And the other one is RAG, retrieval augmented generation. There are also fine-tuning options, like if you have more advanced use case where you need high accuracy of the output. But if you're starting and testing the water, probably you're better with the prompt engineering because that's a low-hanging fruit. You can get better results with it as long as you do a little bit of RAG by augmenting the prompts with relevant data. So why do we need prompt engineering? Basically, we have a variety of models, variety of training techniques, and when you use GPT or other public models for your general use case, like planning your vacation or asking guidance on road trips, they have trained on very huge amount of data available in the internet. They can easily answer for you. However, when you're working with enterprise data, there is no knowledge about this data. These models have a general knowledge with no speciality. So we need to teach and find a way to communicate with this model and get the expected response from this model. That's the primary reason we do prompt engineering. Basically, we are going to give an instruction and fine-tune the instruction and make sure we are getting the response we want. And for most part, we do use prompt builder for that purpose. And there are two key concepts I want you to understand before we go deep dive into prompt engineering. The first one is context window. And the context window is basically the amount of information the model can look up while executing your prompt. So for example, if you're asking a question, if the model cannot find the information you are looking for in the prompt, it's going to be creative and give you a guessed answer. That's what we call as hallucination mostly. However, you can fix this problem by providing the context, and the model have the ability to learn in context, which is at the execution time, and provide you a better response. That's what is called as in-context learning. For most of you interested in prompt engineering and RAG techniques, these are two important concepts to remember, but this is how we are training an external model to do certain things what we want through these techniques. So I talked about prompt. I think there are no standards for how to write a good prompts. There are multiple models and a lot of things are emerging. However, there are certain things we could ask nicely the model so that it can understand what we are asking and we could get a better output from it. Those are like, you could have a system instruction, like where you can tell the model what you want, I mean in your prompt, what you're trying to do. And then you can provide some example, then you could have some validations, and then you could inject your transaction data, and then you could tell what response format you want, and then any user questions or prompts, then again, you can have an optional system prompts. The reason we do that is because the model have zero knowledge about your enterprise data. And most of the time when you do GPT, you're doing what is called zero-shot prompting. And that doesn't work in the enterprise use case because we do not, the model is going to hallucinate if you do that. So don't worry about this. We'll cover a little bit more on this as we go through the demo. Our first use case for today is called few-shot prompting. This is our first design pattern. Like I said, when you use GPT for asking questions, you are most of the time doing a zero-shot. Why it's called zero-shot? Because the model already trained with the information available from the internet, and it's trying to answer based on that. However, when you're trying to ask the model, for example, what are my opportunities for today, it's going to tell you you can do a 4K run, or you can be an entrepreneur, or you can change your job, but it's not going to know that you're looking actually for the opportunity record in your Salesforce system. So to fix the problem, using the techniques we just saw, like context learning and context window, we are going to provide few examples for the model, and the model is going to quickly learn and provide the expected response with high degree of accuracy. So most of you interested in prompt engineering or getting started, few-shot prompting is your best place to get started because it's going to give you a lot of benefits very quickly. Let's jump into the few-shot prompting demo. So before we go here, I'll just flash the JSON. So basically here, I have a simple JSON file of invoices, and I'm just going to predict category for each one of these products, which is missing in this JSON. Just by providing few examples, we'll figure out how the model is going to provide the feedback we want. Let me do a little bit of maximization here. So this is the prompt builder, and like we discussed about the prompt element a little bit earlier, this is the system instruction part where you give the model what exactly you want to do. Here I'm telling you are an invoice agent, analyze the JSON, extract data, blah, blah, blah. And then you must answer only in the JSON format. This sets the context for the model. And then here I'm doing the few-shot example here. I'm describing the categories and what categories each keywords belongs. So the model reads it and quickly understands that this is what I'm expecting. So basically, we are doing a text classification on the fly with few short examples. And here I'm defining the inputs, like what is my good input example will look like. And I'm providing an explanation here for the model, like why it is valid. Similarly, I have provided an explanation for why it is bad as well. So if the response is not a proper JSON, do not consider this as a good example, so it can provide valid exceptions. So, and also, most of the time, if you do not give the response format for the prompts, it's going to give its own way, which is not an ideal way when we want to build when we want to build an application. So we do want to provide an example response format for the model to learn and provide. And so here, I provided the example format for it. So it's going to learn and give the response in the way I want it. So here I'm simply calling an Apex function to pull my file, and it's going to convert the file from blob to base64 and then provide it to the model. Here I'm asking some basic questions, whether this is an input valid data or not. And if everything is good, then populate the response. And finally, I'm repeating some of the instruction here. It's a good practice. Always you can repeat some key instruction in the end as well, so the model always provides the better response. So let's run it through here. I'm going to pull the same invoice data here. Okay, so let's do the preview. So as expected, this is a little bit hard to see here. Let me close this. This is a little bit hard to see here, but if you see here, it's completed without any exception, and it predicted the categories for each one of the product line, like we described in our few shot example. So that's few shot example. So let's quickly go to the next slide. So we saw few shot example. Few shot is a very good starting point. However, when you want to do a more complex reasoning like analytical or math problem, it may not help you to get there. So you do need chain of thought techniques where you explain the model how to solve a complex problem step by step, and then the model can follow it, and then it can solve it for the future problems. So that's the chain of thought prompting. So those of you follow news, I think the new Strawberry OpenAI model also kind of uses this COT pattern. So this is pretty advanced. You can use it for solving more complex, challenging problems. Again, all of this is possible due to the context window and the in-context learning, in which the model learns at the runtime and then provides you a better feedback. However, after you executed the prompt, the model does not have any memory, because predominantly of the prompt engineering technique does not update any model weights or state. That means that you have to keep updating your prompt and keep it in sync. Let's quickly look at the logical solving example. So I have a similar type of prompt here. So I have the same instruction, but the key thing here is the step-by-step reasoning. I'm asking the model to do a step-by-step reasoning. Even when you try your GPTs at your own time, you can ask the model to do a simply ask step-by-step reasoning. You'll see a completely different set of results than the usual results you get. And similarly, I'm providing the examples for here. Here I have an invoice data collection and a sales order data collection. What I'm trying to do is I'm trying to match the invoice with the sales order data, and then I'm asking the prompt to do all the arithmetic calculation. For example, I'm doing here. First, I'm trying to match the supplier ID between both the collection. Then I'm doing some arithmetic operations like calculating the total price and subtotal. And then I'm doing some amount validation, they are matching or not. And similarly, I'm making sure the SKUs between these two collections are same as well. And then finally, I'm telling the model, if everything is looking good, then go and approve this invoice. And then this is the expected invoice format, as expected response format as well for the model to respond with me. Here I have two data collections. One is invoice data and sales order data, which the prompt is going to use while executing it. And again, I only want the JSON response. So let me execute this. I already have the data here. First, I'm going to do a negative example. Let's see whether it fails. What happened? It's taking a few minutes. So here, as we expected, since I changed my data, it says that sales order number does not match, and the total price is also not matching. So that's how it is doing reasoning using the following step-by-step reasoning process we defined. And let me quickly change this data back, and let's run it again. Let's run it again. This time I'm expecting it to be approved because, yeah, it is approved, and no, there is no exception because everything is perfectly matched. So it is approved. That's chain of thought prompting. The last technique is called prompt chaining, and prompt chaining is basically if you want to execute a complex workflow, like using multiple prompts and multiple specialty models, that's where you use the prompt chaining. It's a simple technique. If you, instead of using one prompt to do everything, you can divide the prompts into multiple subtasks and execute multiple subtasks as a different prompts. It's not only a good design, but it also provides you an opportunity to optimize your cost as well, and also it yields better performance. For this demo, I'm going to show you an end-to-end example of how you can process a PDF invoice all the way to the payment just by applying all the techniques. So here for prompt chaining, it's a little bit more complex. I'm using 3 prompts here. The first prompt is a multimodal prompt. I'm going to use the Gemini API to call the Gemini prompt API. I'm going to send the PDF blob from Salesforce, and it's going to execute, and it's going to return a JSON data for us in real time. And then I'm going to apply the few short prompting as well as the chain of thought prompting techniques to read this JSON, validate this JSON, and perform a two-way matching between this, and do some arithmetic calculation as well, and provide an output. If everything is valid, I'm executing the final validation prompt as well. I'm doing an extra validation, making sure that everything is good. Then if everything is good, then we can go ahead and approve and create a payment payment record. So let's look at this one. So let's look at the invoice first. This is our PDF invoice document. Here I have a seller, I have a client, and then I have some few lines in the PDF format. This is an actual PDF format. So we are going to get all of this data through, information extracted through the Gemini prompt first, and then we are going to execute it. So this is my flow, and for this one, I'm just going to do the debug first because it's going to take few seconds to run. Let me grab the ID first. While it's running, I will explain this. So basically what we are doing is first we are getting the sales order information, and then we are retrieving the file information. Then we are calling the GPT prompt to do the PDF extraction. If everything is good, then we are retrieving the sales order JSON from Salesforce through Apex action. And then we are doing our chain of thought prompting to compare the results. And then we are doing our final validation prompt as well. So if everything is good, then we show a success message. And if the user wants, they can go and create a payment record. So all of this done through simple flow mechanism. Let's look at the prompt result. I know it's a little bit difficult to read here. So the flow started, and as you see, the first one is the Gemini prompt, where we got the actual JSON response as an output. And then it is sent to the chain of thought prompt, where we have the sales order data from Salesforce, as well as the invoice data from the Gemini prompt, which we executed earlier. And then it did all the validation, it did all the matching, and let's check. The invoice is approved, and there is no exception here. And if everything is, even though it's approved, we are doing a one more validation round to make sure that everything is in the format we want. And since everything is good, I'm just going to click here to execute the payment. As you see here, finally it went and created a payment record for us. Let's go and check the order screen. Hopefully. So it created a payment record for us. So as you see from this example, you can execute a complex workflow from invoice to payment just through a series of prompts, which might have taken a lot of engineering work earlier. But however, through the prompting mechanism, we are solving it very simply. Let me go into that. So this is my last slide. So prompt engineering, like any other software engineering, it requires rigorous development, testing, and monitoring and iteration. So treat prompt engineering as an engineering problem, not just simply as writing a text problem. And you do need a lot of tools. I didn't talk anything about the security or data privacy of it. There are other good discussions happening. I would request you to check out some of the platform tools like event monitoring, data detect, and data masking, things like that. And with that, this is the resource. I will publish the GitHub resource probably in a couple of days. And thank you very much for your time. I hope you enjoyed it. I hope you find it useful. Thank you very much. I appreciate it. Thank you.